Section 114, how vectors transform. If you want to, you start with the vector that is expressed by in some basis vectors. And what happens if you want to express this in a different set of basis vectors? So, you know, let's say you have your I hat, j hat, and then k hat coming straight at you. And then you want to rotate that somehow, so now you have, like, let's say your j hat is pointing that way, I hat is pointing that way, and j and k hat are both, so I hat and k hat are both coming out of the page. You know, you have the same vector. You know, a vector hasn't changed, it's just you're expressing it in different, with different components. And he walks through like a rotation through 2 dimensions, and then he jumps to and says that in 3 dimensions you basically have this formula, some rotation vector, rotation matrix. You have xx, xy, and the z's, and times your ax, ay, and az components. And that's how you rotate the components into the new system. And, you know, as a shorthand, you have, I use capital letters. Oh well. So the ith component of the new component system is equal to the sum from j equals 1 to 3 of the ij component of the rotation vector times the j component of the original axes. So that's just basically how you do matrix multiplication. Then he talks about tensors. I don't know why you'd want to rotate tensors at this point in your career, but there's a note on how to do it. So I guess if you look back at this book and you know what tensors are and you want to rotate them, then it'll tell you. So pretty simple stuff.